picture. So normally how the image will be processed. So any image you take it will be represented in the form of a matrix where it will be in the form of a pixels. So we use from 0 to 255. Any image will be represented as a pixel, collection of pixels only. And again we use grayscale and the color scale. If it is a color image, red, green, blue colors will be used, or it will be a black and white images. Whatever it may be, it will be represented in the form of a pixel. So normally when you want to purchase a mobile phone and you focus on the camera of your mobile phone, how do you ask about it? What is the pixel of your camera? When the pixel rate is high, when the pixel is more, obviously the quality of the image what you take, quality of the video, quality of the photo will be very, very good. And nowadays we used to take selfie and we used to take a lot of videos, photos, and for various social medias also we are using our photos or videos, whatever it may be we are capturing. We look for the quality of the video, quality of the image. That's why if you see the recent mobile phones like Vivo or MI, these mobile phones, comparing with the earlier or the Samsung or some other brand, it has been more clear because they are using AI into that. They are using convolutional network algorithms into that. That is the reason, because it even does the filter. Many pictures we take, normally we take and it will beautify the picture and it will show. Right? People who are using Instagram and all, you used to post your pictures or images or any videos, it will look so beautiful but naturally it won't. Okay, it beautifies the images and then give. That is possible with convolutional neural networks. How it does? That is very important. Whether if I give my whole image, it may be a face or the whole picture, will it be able to process entirely? The traditional algorithm considers the entire image, converts that as a vector, it will flatten it as a vector and then it processes, so the accuracy will not be so good. What convolutional networks is going to do here? It will take a patch of it, like it won't take the complete image. Okay, so in the tradition, it will be converted as a vector. Vector is processed, again it is reconverted to image. Whenever you do some, so the accuracy, if you see, since we are flattening it as a vector or matrix, what happens in the image, the pixels in the image it may be very closer. Like if you consider this as a 16 by 16 matrix. I'm not going to draw that many lines over here. Just have an assumption it is a 16 by 16 because everything comes with it 0 to 255 only. So it is a 16 by 16 matrix. So any image, or I'm just writing a letter like this. I'm writing a letter like this. Okay. So consider this as an image. How it will recognize this image? Like you are writing an answer. Okay, online examination you are writing. So you are selecting option as A. So it has to check whether this A, if you are asked to write, you are not clicking or you are not selecting, you are writing the answer. Okay, so that answer is matching with whatever is already stored. So that needs to be compared. Or you are drawing something, you are giving it as a picturization, some image you need to give. That image has to be compared with the already stored image. So when it is comparing, first this will be converted as a, normally in any other traditional process, this will be converted as a vector, and that vector is processed. That side also it will be converted as a vector. Both will be compared. Here, what is the problem with this? Suppose very close to this, like if you closely see this, in this you cannot see the real system. If you see, you will be able to understand. So this pixel may be in some place, maybe around 40, whereas the very next pixel may not be very close to that. It may be after 10, because we matrix, this will not take the exact value. That is the reason when you process it, it will not be able to give the accurate value. But it does. It does. But sometimes when there is a slight changes on it also, it will not be able to recognize. Imagine now we are using biometrics. We are, we are giving our face as an entry. So our face has to be compared with the already stored face. Okay. So every time if it is taking the whole image and comparing, it will not be that easy or it will not be so accurate. So it will take only a particular feature in the face. It will take only a particular feature. As you all know, our eyes will never be changed. From the childhood till you die, eye will not be changed. Okay. So it will compare, it will take only a particular very important features that alone will be extracted and that will be processed for the image processing. That will be compared with the stored pattern. It is not always for the stored pattern. For any image processing, for any video processing, some features from the image directly. Please understand one thing. In the tradition, it converted as a numerical. Then the numerical value only will be converted. When the numerical is getting converted for the image, there will not be an accurate result. Whereas when you involve convolutional network into that, image will be taken as it is. Image will be taken as it is. There won't be any changes. What exactly it does? It extracts only few features, or instead of taking the complete image, every time frame by frame or slide by slide it will start open. I'll just give you overview about it, then we will go to the content. Okay. So if you are taking this kind of matrix, so we said something called a filter. We said something called a filter, which we call it as a convolution. Which we call it as a convolution in CNN. So this is the one which is going to use for the testing. So the entire thing will be matched over here. So this one will be first processed. We do some dot matrix multiplication and all. So it does and it creates some value. Then this frame will be slowly moved to the next and then next and then next. So like that it moves, like the filter is checked on the image directly frame by frame. We say it is a sliding and this operation is called the convolution operation. Please understand, in the traditional ANN, the image is converted as a vector matrix and then comparison will be taken place. Whereas in CNN, because this image processing or video processing is very important applications, AI give more focus on vision, not only for the text. That is the reason this convolution CNN is very important in AI. Okay, because instead of converting to a numerical and the numerical is getting processed, here we take the image directly, the image is getting processed. Similarly, the video also will be compared. Okay, fine. So take down a few important points and then we proceed. A convolutional neural network is a type of deep learning neural network. A convolutional neural network is a type of deep learning neural network architecture commonly used in computer vision. Commonly used in computer vision. A convolutional neural network or CNN is a type of deep learning neural network architecture commonly used in computer vision. So as we all know, computer vision is the field of artificial intelligence which is mainly used for the image processing and video processing. So normally neural networks uses various type of data sets. We know that, in which text is also having a very important role over there. The other one is a image or video. That's why we give focus on it. Yeah. So anything we see with the architecture, what and all will be there in ANN, what and all will be there, what and all the different layers, any ANN. We have seen makes the difference between each and every ANN algorithms or ANN models. Hidden layer, each hidden layer will be having a different function. And another very important thing here is activation function. In a simple neuron, if you consider, there will be in any single neuron, there will be an activation function. Okay, so you have an input and then you have a weight, and that is getting processed and that is computed with the activation function to produce the output of a single neuron. Like each and every neuron may have a different activation function. So this activation functions are all will be available within the hidden layers. Okay, within the hidden layer you have plenty of activation functions. So like that, even in CNN we will be having an architecture where different some more new layers we are going to see. As it is CNN, we will be having convolution layer. Convolution layer. In addition to that, we will be having a fully connected layer. Let us see the architecture. Please remember, for this the input will be image. Input will be image. So I name this as input layer. CNN architecture. It is comprised of various layers, starting with the input layer, and the input will be always an image as it is used for image and video processing. So this is called convolution layer. Another layer what we see here is pool or pooling layer. We will see each and every component one by one. Next is dense layer. So if you are using only machine learning, there we will be converting the image or processing the image by converting image as a vector matrix, and then we do process. Whereas in deep learning neural network, we process the image directly. So that you need to register in your mind. So after the convolution layer only, our dense layer comes. Whereas in machine learning, this will not be available. Directly the dense layer will be there, and here is the process where the conversion process will be taken place. But in CNN, you have a convolution layer which will be performing a convolution operation or function, which is very, very important here. Yes, after the dense layer, you have output. About this, let us see directly this convolution. Have you completed? Yes. So image is given as the input. Our convolution layer will be extracting the features of the image. This extraction is nothing but at every time we do perform the sliding over the actual image. So you are setting a filter of some particular size. Normally the default size will be a 3x3 matrix. That is nothing but convolution or filter. However you get name it. So you set a convolution or the filter. Using the filter we do extract the image, and that will be done by the convolution layer. We will see in detail how extraction is done. Okay, so for the introduction, this is in a convolution layer, performs convolution operation with which is nothing but it creates a filter, and the filter extracts the image, extracts the features in image. Okay, so the entire image cannot be considered directly, so you take a portion of it. You take a portion of it with the less height and then less RGB value. With that, I will give you another example with that. Yes. So this pooling layer will downsample the image. That is, this will be extracted too large, we will compress it and then send it. We will compress and send it. Will it affect the quality of the textile image? It will not affect the quality of it. It will not affect the quality of it. It occupies less space, so we are able to send it across the network. Not only the network, whenever you are transmitting from any one source to destination, it is possible. Okay, so here this downsampling, what it does, the complexity of the computation, to reduce it, it performs some operation. So detailing we will be seeing about this also. Next comes to dense layer. So this dense layer, again you should go back to the original message. You should go back to the original message. Like you are making a, as I mentioned, we have registered our face. Okay, so every day when we are coming, we are showing our face to that machine. It recognizes us and then only it will say thank you or valid or something like that. Okay, so it performs the matching with the already stored one. So here this dense layer will take care of that. It will make a comparison with the original image. So it extracts here and there also extraction will be taken place. Both of them will be compared. Suppose imagine here in the database it extracts the nose portion, whereas here it is extracting some other features of face. When it makes a comparison, it will not be able to match. So this log is taking care of that comparison with the original images. Okay, and finally produces the output. So this is the overall CNN architecture. So we will be seeing everything in detail. Kindly make a note of this. Convolution layer applies filters to the input image. Applies filters to the input image. To extract features. To extract features. The pooling layer downsamples the image. The pooling layer downsamples the image to reduce the computation, and the fully connected layer, yeah, this I have not given name. Fully connected layer, fully connected layer, it will perform the prediction. Fully connected layer makes the final prediction. So this part will be done with the help of back propagation. What do you mean by back propagation? Some people have answered in the exam also. Back propagation. So we will creatively perform. So many epochs we will be doing it. So first epoch, if you do it, it will check the error rate. It will check the loss. It will check the loss. So based on that, the next step will be performed. Okay. So every time it will check the result of the previous step. Based on that, the next iteration will be performed. That we call it as a back propagation. Back propagation. So this fully layer will function by using back propagation logic or system. So now let us see how the convolution network works. Operation, we can say CNN operation, or that I am going to take one simple image. And one more point you need to remember here, always CNN share the parameters. Sharing parameter is its property. Share the parameters. What is this share the parameters? You take the actual image, from that we are going to extract the thing. Okay. So whatever the thing you consider for any image, it may be height, width or some other attributes you are taking for an image, which all those parameters will be shared for the extraction or to the filter. Okay. Whatever you see in the full image, same thing will be there even the extracted image, or at any point of time you slide your image. You slide the entire matrix. In that one frame only you are going to consider. Each and every slide will be having all the attributes of the actual image. As simple as that. Okay, fine. So we are going to take one image, a very simple cuboid. this image. It is just a cuboid. Yes. So in the entire image, actually entire image only is going to be processed. Okay. As a concept, if the entire image is going to be processed, there is no conversion over here. But how this is going to be processed? So you take a small patch of this. You take a small portion of it, and that will be processed. That also will be having some width, height, RGB and all those things, but it will be lesser than that. Okay, so now you please correlate this, or please no talking. Suppose I consider the entire image as there is no conversion. This is just to make you to understand. Yeah, listen here. So this is my whole image. My whole image, which is being represented by 6 by 6 matrix. 6 by 6 matrix. It is all having some values. Like depending upon the pixel, it is having some value like 5, 2, 1, 0, 2, 1, something like that. You can fill any values over here. And this filter or convolution, I am having a value as something like that. 1, 0, 1, minus 1, 1, 1, 0. This is my filter or convolution. Okay, please try to understand. This is the actual image. We are going to extract a portion of this image, a patch of this image, and that image also will be a shape of cuboid only. So even if you extract also, image will not be changed. It will also be having some width, height and this RGB, but it will be smaller than the actual one because we are taking a patch of this only. And again by assumption or imagination only, the entire image is being represented as a 6 by 6 matrix. 6 by 6 matrix, and my convolution or the filter is represented as a 3 by 3 matrix. So internally what it does, it performs some mathematical computation. Okay, so processing means it is not like whatever we see internally, some computation is taken place. Hey, Sairago, what do you want? So listen here, how the computation is taken place. As I mentioned, first this filter. This is called filter or convolution function. However, we can call this filter is kept over here. Imagine it will be operating here. Okay, so everything will be having some value. You can fill this randomly. I am giving some value. We are not taking the exact thing. Okay, so this is kept over here, and it performs one dot matrix computation. Dot matrix computation. It produces a result which will be again in the form of a matrix. For this particular thing, it will be creating a 4 by 4 matrix. So after this computation, it is producing some value, something called 4. Okay, so 4, 2, 1, 1, 3, 4, something like that. It produces. Actually, when you do one filtration on this, one sliding, it will be able to create only one value. What is the computation is so depth, that will be dealt later. Now we are only in the introduction. Okay, so you are keeping the frame over here, you are keeping the filter over here, you are extracting. The extraction result is 4. Similarly here, you have a filter. The filter will be of a small cuboid. That cuboid will be kept any portion of this. This also will be a, so here, this portion I am extracting. This portion I am extracting. So this is producing some result that also will be in the form of a cuboid only. So that is nothing but this value 4. you are keeping this filter over here. It is performing the computation and producing some result. Then you are keeping this. So we have covered everything now because it is a 3 by 3 matrix. Beyond that you cannot go. That is the reason I said it will create a 4 by 4 matrix value. So this may be creating some value. Similarly, next to 3, next to 3, next to 3 creates this value. So this will be your output. So what we have done, filter is mapping to the actual image, creating some extracted value. So we are talking only about the convolution operation or convolution layer. We have not gone to the next layer. Only convolution layer. What it does, you set the filter or a convolution function. Convolution will be slided over the actual matrix or actual image, which will be creating an extracted features. Extracted features. Clear? Don't worry about the values. Just I have shown this value because internally there will be a dot matrix multiplication will be taken place. Okay? So whatever the filter size you get, only that much portion only can become taken at any point of time for the computation or processing. It's clear? So sliding is very important thing. So this filter is otherwise called as even kernel. We say it is even kernel. Make a note of it. So we take a small patch of the image. We take a small patch of the image and run a small NN neural network called a filter or kernel. Then we slide the filter on the original image. Slide the filter on the original image. As a result, we will get another image. As a result, we will get another image which will be having a different height and width. It will be having a different height and width. Okay, so once you process this, you get another image, that is this image, which will be having a different height and width. So you take a small filter and keep it over here. You try to extract, that will create one image which will be smaller than this. Like that, you do it on all the portions of your image, and that will be done with the help of a convolution network. What we are doing, we are processing the image as it is. We are not converting. That is the main difference over here. Okay, so why CNN came into existence? There are various reasons. As I mentioned, traditional ANN converts this as a vector matrix, due to which it faced two problems, like spatial problem, which I had shown it, like in one pixel if you see, that will be having value something around 25. The very next, very close by to that pixel will be having a pixel value as some 45 or 50. Due to that, the accuracy is last. Spatial problem. Another problem is the translation problem. So since the translation image to vector to image, due to the translation, again it takes long computation time. So to avoid these two things only, mainly CNN came into existence. What are all the functions CNN can do? Like this is as I mentioned, it will recognize our face or any image is given as an input. It will be able to recognize the image as well as the video. Not only that, it will be able to identify the gestures also. Sometimes you just want to show your hand performing. You see if you get a chance, okay? So in nowadays, what like the mobile, the advanced mobiles and all, various functions are there. Those functions are just by saying like you want to log in something, rather than you give your credential, name and password, the front camera will just capture your image and you will log in. It is able to recognize that is you are the authorized person, so it will log in. You don't have to type everything and log, just by seeing the face how it is done. Those are all the advanced functions which is being incorporated on various gadgets. That is because of these algorithms. Okay, these are all the applications which we enjoy in our day-to-day life. Okay, fine. So we'll continue with the mathematical part of it. So diagrammatically we have seen. So mathematics is playing very important role in convolutional function. What are all the mathematical functions we see here? Mathematical part. Now you only need to write because it is all very important. Convolution layer consists of a set of learnable filters. Learnable filters, that is, you create the filters, right? You create the filters and you are applying on the original image how many filters you are using or how many times you are sliding over there. Or for the same image, are you creating more than one filter? So that thing is very important. So any CNN will be having plenty of learnable filters. Learnable filters. Convolution layer consists of set of learnable filters within bracket kernels having a small width and height, and the same depth as that of input volume. So normally, as I mentioned, we take 3 by 3 the filter size, but it can be, suppose you require more accuracy, you may go with the different size also, right? So during the forward pass, we slide each filter. During the forward pass, we slide each filter across the whole input step by step, where each step is called stride. What we did here is called stride. Each time you are sliding, which we call it as stride. And compute dot product between the kernel weights and patch from input volume and patch from input image. You can write input image, patch from input image, right? So you have a kernel and you are performing sliding over here, and that time we perform dot matrix with this, and that is taken for the dot product or dot multiplication. As we slide our filters, we will get a 2D output. As we slide our filters, we will get a 2D output for each filter, and we will stack them together. As a result. We will stack them together as a result. We will get output volume having a depth equal to the output volume having a depth propagation